Hello everyone. I'm going to show you how to turn an empty, seemingly useless WD-40 can and an old spark plug into a remarkably powerful and versatile DIY tool. I'm starting with a standard empty WD-40 can. The shape and thin metal of this can will serve as the perfect housing for our project. Next, I need to mark a clear line around the circumference of the can. I'm using a roll of tape as a guide to draw a perfectly straight line with my marker. This will help me make a clean, level cut later. I'll secure the can in a vise and carefully use an angle grinder to cut along the line I just drew. I'm taking my time here to ensure a straight cut and to avoid deforming the thin metal. Now, I'm taking the top half of the can and using scissors to trim and refine the rim around it. I'm using pliers to remove the tube from inside the WD-40 bottle. I'm using scissors to cut small strips along the edge of the can. I'm doing this to create a sturdy base and a protective housing for the electrical components that will go inside. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Using a hammer, I'm carefully bending those cut strips inward. This is a very important step because it folds the sharp edges away, preventing any accidental cuts when handling the tool, and it gives the base a nice, finished look. Next, I'm working on the top of the can, using a drill to create holes for attaching the heating element. I'm using a step drill bit to widen the hole. The step bit is perfect for this because it slowly enlarges the hole without tearing the thin aluminum, allowing for a precise fit. Now for a key component, an old spark plug. Spark plugs are built to withstand immense heat and high voltage, which makes them the ideal central insulator and conductor for our high-temperature tool. I'm taking a piece of red electrical wire and stripping off the outer insulation. I'm tightly wrapping the copper strands around the electrode of the spark plug. If you find this video interesting, Don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. At the other end of the red wire, I'm stripping the insulation and twisting the copper wire tightly. I'm wrapping the copper wire around the threaded part of the spark plug and tightening it. This creates a solid, secure electrical connection for one side of our circuit. A tight wrap is crucial to prevent arcing inside the handle. Next, I'm dismantling a standard electrical terminal block to extract one of the brass connectors. I'll slide this brass connector over the top terminal of the spark plug and tighten the screw. This will hold our heating elements securely in place. I'm taking a longer red wire and stripping off the insulation. I'm attaching the wire to the spark plug and securing it firmly. Then, I'm wrapping the entire connection thoroughly with red electrical tape. This insulation is absolutely critical for safety, to ensure the current only flows exactly where we want it to. I'll thread the wire through the hole we made earlier and then firmly screw the spark plug directly into the hole in the top half of the WD-40 can. The threads bite right into the aluminum, holding it tight. To complete the power lead, I'm stripping the end of the red wire and attaching a heavy-duty alligator clip. This will allow for a quick and easy connection to our battery source later. Here's where it gets really interesting. I'm dismantling an old, dead AA battery. We are after the solid carbon rod hidden inside. carbon is an exceptional conductor that can handle extreme temperatures without melting, making it perfect for our electrode. I'll secure the carbon rod in my drill and spin it against some sandpaper to sharpen the tip. Creating this fine point is essential because it concentrates the electrical arc, giving us a very localized and intense heat source. Now, I'll carefully insert the sharpened carbon rod into the brass connector on the tip of our tool and tighten the screw to lock it in. I'm preparing a separate blue wire with an alligator clip to act as our ground line. I'm hooking this up to a 12-volt motorcycle battery. I'll connect the red clip to the positive terminal and the blue ground wire to the negative. Watch what happens when the carbon touches the ground clip. That bright flash is a high-heat electrical arc. Let's put it to work. I've attached the ground clip to some razor blades. When I touch the carbon tip to the metal, the intense concentrated heat instantly spot welds the thin steel blades together. It works incredibly well. Here I have two wires and I've twisted the two copper wires tightly together. The focused arc acts like a mini carbon arc welder, easily melting the copper and fusing the two wires into a solid joint. The heat control is surprisingly good. Try this with a larger object like this bolt and nut. I'll attach a grounding clamp to the bolt and weld the bolt to the nut. Watch how quickly the charcoal stick starts glowing red. This highly concentrated heat is incredibly useful for securely welding nut to bolt or even for welding light metals. See how fast and bright that gets? And there you have it, an incredibly powerful and versatile heating tool built from scraps. If you enjoyed this build and found it helpful, please give this video a huge thumbs up, share it with your fellow DIYers, and drop a comment letting me know what you'd build with this. Don't forget to subscribe for more awesome projects. Thank you so much for watching, and I'll see you in the next video.